Hello, I'm Aniruddha Mukherjee and I'm from the team ForgEye. We are trying to solve a problem of ladle tracking and optimizing the steel industry. What our problem statement is using OCR to track a ladle and create lots of metrics, which then we can apply ML on and improve the efficiency and profitability. Here are my team members Akshat, me, Yashvardhan, Kumar, Priyasha, Akshat Vyas, and our two mentors. Now I would like to explain the entire problem statement with a flowchart. This is our flowchart. Basically, in the steel industry, there are ladles moving which have numbers written on them. What we are doing is we are taking visual input using a ESP32 camera module. Then we are passing this visual input or camera input through to the MQTT framework. This is an industrial standard middleware. This is used in IIoT applications or industrial Internet of Things applications. This really helps in scalability and when there's huge amount of data that needs to be processed. What this does is it breaks the data into packets. These packets then are transferred easily and it saves bandwidth. The images are then transferred to the Raspberry Pi. This is our central intermediate node. Through this, all the magic happens. The Raspberry Pi then transfers those images to the ML models. We have two ML models, OCR and hotspot detection. OCR is used to track the ladle number, and hotspot detection is used to detect if there is a hotspot using thermal sensing images. Once we have detected the number on the ladle through a machine learning model which we have used, that goes to the website which has a server. In the website also communicates with the Raspberry Pi. The website then uses all the data in its database from the ML model, from the Raspberry Pi, etc. to create advanced analytics apps. Later on, I will show you the website and the ML model. Right now, I would like to move to the website. This is the website. Right now, it's showing the factory layout. Over here, you can imagine a map of the factory, which we didn't have. That's why we put this placeholder image. And animations on what is going on at which station and when. Here we have an image of the ladle or the camera. And over here, you can imagine the number being printed. These are the turnaround times of the ladles, 6, 7, 8 as being displayed when you hover over. This is the ladle tracking system where it shows the life, the humidity, the weight, etc. And this is the life monitoring. The ladle starts and then slowly dips, etc. through maintenance, etc. Now I will go to LTS or the ladle tracking system. Over here we have the ID of the ladle, the current location, the life, the condition, whether it's filled, whether it's in progress, whether it's completed, what is the type of it currently going on, is it running, waiting, what is its status, etc. We have another page on our website called the Red Spot. This is a web app. So over here, you can imagine a thermal image coming and my ML model detecting whether there is a red spot there, and if there is a red spot or a hot spot, so-called, that has to be taken care of immediately as it can lead to failures. We have a camera dashboard. Currently, it's just showing the same feed, but in the real industry, there would be feeds from various cameras, 1, 2, 4, 5, each having different names as they are for different stations, and displaying the status, what is going on in that station, where the ladle is, the number of the ladle, etc. Lastly, we have logs. Inside logs, we have a continuous update for people to check what happened in the past, where something went wrong, or whether we can optimize stuff. Over here, for example, at 6:30, production line for ladle 3 started. Then quality inspection was going on, etc., etc. It goes on. Now, I would like to show you the ML model, how OCR is occurring. This is the model we have used. These are the input images, 8, 5, 12, and the number on top in yellow is the predicted number by the model, by the machine learning model. This is a very interesting machine learning model. We use a CRNN, convolutional recurrent neural network, and this has 3 subparts which are explained in detail in the event idea. Over here, I have explained the model in detail. Again, these are further images. Lastly, I would also like to say that all this code is available in the GitHub repository, whose link we have shared in our abstract and event idea. Thank you so much for listening to my presentation. This is our PPT. Again, here is the same flowchart I showed you. These are the technologies we have used: Python, AWS for the cloud front, NumPy, MySQL for the database, MQTT is what I said is the advanced industrial IIoT system, Matplotlib for graphs, etc. Finally, we have included an additional document. Over here, I've included the flowchart again, the ML model. This is how the CRNN model works in the backend. There's convolutional layers, then recurrent layers, then a transcription layer. So CR neural network, NN. Convolutional recurrent NN neural network. We use the CTC also, which is another very interesting technique, also explained in detail in our event idea. These are the screenshots of the web app that I displayed in the video. This is hotspot detection, is what I was trying to explain in the web app. Suppose you have an RGB image of the ladle where the colors indicate the temperature. White means very hot. So the model currently can detect a contour around this white spot, which is very hot and needs immediate attention. For exact temperature measurements, we may need a thermal camera that also relays the temperature with the coloring. Currently, we just took PNG images and trained a model to detect the white spots. Thank you so much for your time.